Those are exciting times. A BBF baby? BBFB. Yes, I'm sure there's, if they did RFCs, April 1st RFCs, there's one in there for them. Yeah, that's cute. Is it just me or is this room smaller than what we usually get, huh?
Yeah, they've been, I mean, in the past, they had always like either too small or too big rooms.
Yeah.
I don't know what. I mean, I think Diego had some struggle with the secretariat. I don't know who's to blame.
Well, they only gave them one session this time, too, and usually we have two.
Yeah, but this time I also heard it's really tight with rooms, and so.
That's why.
I don't know.
I did open, or I did tell the tools guy, hey, this is the experience you and I were having where...
Oh, yeah.
Yeah.
Yeah, I think they are doing some updates. So some things didn't work this week, but I think they're happy for feedback. Actually, we can offer the clicker.
Are you sure it works with your...
Mm-hmm.
スタンダードになる前に、ユースソケットのことも考えてやってもらおうということをしたんですけど、あんまりプライオリティが置かれなかった。結局、その辺は忘れて、多くしていくということだったので、我々も他のことが忙しくなってつながった。ソケットを入れるソケットに使われるようにはなっているし、ソケット以外についてトランスファーアドプションは普通に良くてですね、もうクロムの方でもだいたい 0.7% ぐらいの PPR がここで持ってわけじゃないです。
Can you keep the agenda open on your laptops?
I'm doing that right now as well, yeah.
やつじゃないところで使われるなので、また誰かが HTTP ワーキンググループソケットを作らないのをできたので、までにちょろちょろと考えていたら、もうソケット専用のスクリーンを作るんじゃなくて、のどっか使う。もう HTTP セマンティックスの中にメッセージングを入れて、で、まあ、あわよくば将来的にはその、まあ、ウェブソケットの API にバインドするというバイディレクショナルストリーミングを HTTP の上でやって、それにちょっとメッセージングをW3C とは W3C も我々今やってるのは API です。フーメル HTTP リクエストの後継なんですけど、はい、それをガンガン活用していて、もうそろそろアップロードもダウンロードもそのチャンクを送れるようになるんです。ダウンロードができているので、それにもう一つ、それをなんか拡張性を考えてストリームして API を作ってるんですけど、ストリームの枠組みの中でコンプレッションストリームとかメッセージングストリームとかそういうものができるようになっているので、ウェブの世界ではウェブのレイヤーの
7 minutes. Oh no, shoot, 3 minutes late. Yes.
If the German is late, then everything is lost.
Oh gosh. I have an excuse, I'm Canadian, huh?
All right, ladies and gentlemen, take your seats. And if you could close the door.
You, sir, coming in the back? Yes?
I think it is.
No? They're doing it for us.
Thank you. All right. So this is the IETF-NFVRG meeting. If that's not what you're looking for, you're in the wrong room. Oh, that doesn't work. Give me 1 second.
Last one in the folder, remember? I think.
Close this one. Oops,
Oh, yeah, that's awesome.
Great.
Hey, while we're waiting, can we get the blue sheet started? You, sir. Yes, would you like to come get one? Thank you. Hey, Heather, do you want to come on up and I'll get you to pass this out on your, I know you know this. Darn
All right.
it. Thank you. Oh, no, there's a pen on there.
Okay, sorry for the glitch. Thanks for coming. We are not Diego and Ramki, so they both couldn't make it this week. So Sarah and I are standing in. So it's a pleasure for us. Let's get started. So you are hopefully aware of the IETF IPR policy. So this applies to this meeting as well. So essentially that says if you are aware of any IPR of things that are presented here or that you are presenting or that are discussed here, you are expected to notify us in a really timely manner. So the chairs asked us to pass this request on to you. So please continue reviewing all the documents. So it's like really essential to establish a good quality. So the group gets many submissions, many contributions. So that's essentially great. But so if you want to have your documents reviewed, maybe you can also help the others. And please also kind of note this is not only like a presentation only activity, right? So I mean, we expect you to have make progress on research questions, have active discussions on the main list. So please also use these tools. Slides are all in the data tracker. There's a main list, website, wiki at the usual locations. So before we get started, we have to sort out two important things. First is note taker. That's really important, as you know. And so normally Sarah and I are doing that. So today we're unfortunately a bit challenged.
Could we get some volunteers for note takers? I could bribe you with a beer. Yes, I've learned from the best. Sake? Ah, winner. Yes, perfect.
Right.
We have one. Could we get a backup note taker? I'm serious about the beer. Sold to you in the back, sir. What's your name?
Yeah.
Oh, and a new attendee. Awesome. Thank you. So please, when you're done, come up and see me. I'll make sure you have my email address so you can send me the minutes when you're done. Oh, I guess yours are on Etherpad, so yours will be live. And then, folks, remember, when you come up to the microphone, state your name slowly and clearly. We have a new attendee taking notes, which means he doesn't know any of you. So saying your name slowly and your affiliation will really help in the minutes. Thank you.
So regarding note taking, I'm not sure if you know. So if you look at the agenda, you find a link to an Etherpad instance. Preferably use that. That's also helpful if someone is missing something, maybe a name. You can just help the person and fill it up. Second thing is JavaScribe. So we will have at least Diego participating remotely. So we would really appreciate if he could get his comments to you. Is anyone on Jabber?
Same beer is on the table. Can anybody log into Jabber?
I mean, the main job is really to monitor the channel and relay some questions.
All right.
All right. So there's no Jabber today. Okay, so just a quick reminder. So there's too much going on in NFV these days that we cannot list all of these things. Please use the mail list to announce relevant events, call for papers, and so on. Please keep this, to the research, like open source kind of activities. Avoid sending marketing material. Can you please close the door? And so it's my pleasure to congratulate Sarah on your new appointment. So she's going to be helping Diego and Ramki with the group in the future. That's great. Apparently, they already rebuilt the wiki. So that's work in progress, I assume. Please look at that and provide feedback. And so a couple of things that may be relevant to the activities in this group. So you're probably aware that, I mean, there's lots of discussion around network slicing, you know, in 5G use cases and so on. And that couple of documents that have been submitted could be good for us to, you know, look at this, understand it, and maybe also, you know, build some idea, some research agenda, perhaps, what could be done. So that was the suggestion by Diego and Ramki. So let's figure out what NFVRG can do in this context. So there's a side meeting later tonight in Studio 3, so on 5G slicing. I guess some of us could be interested. So for this meeting, so as usual, we have a pretty packed agenda. So in order to give everyone a fair chance to present their material, we have to be a bit strict on the time management. So we will really keep the time and stick to it, and we will at some point have to kick you off the stage. So we give you a 2 minutes warning, though. So please try to manage that. So we have, I mean, seen the material. Some of you have really many slides. It seems like it could be really challenging. Please try to figure out how to manage that yourself. And that brings us to the agenda. So there's one change we applied compared to the posted agenda. So we're taking the OPNFV update first. So Heather has an important conflict and has to leave pretty soon. And we'll talk then first about our group drafts and updates on proposed drafts, and then and reports on various research and open source activities. And if there's any time left, so if you have any other announcement to make, we can use that for that. All right. Is there any question, comment, any JavaScript?
Any bash with the agenda? Moving right along.
All right. No. It's my pleasure to welcome Heather to the stage.
Ooh.
Do you want to use this?
Pink box.
Okay.
All right, the last one of these I had trouble with. All right, so hey, I have a flight to catch, so I am going to probably try to do this in a fairly quick fashion. But so, hi, I'm Heather Kirksey. I head up the OPNFV project. I've come to talk to the NFVRG a couple times with updates on the project. So thanks for letting me come back again. So just as a reminder, OPNFV is the open source project that works on NFV, and we do that through system level integration, testing, and working with upstream projects to integrate new features and capabilities relevant for NFV use cases. I've shown this diagram before, but basically sort of, so where we build a stack or sort of a series of stacks as a platform, drawing from various other pieces of work going on upstream. And then we do testing, deployment, integration, and documentation and new feature work around that. So just reminding everybody, the bulk of this presentation is about sort of our most recent release, Colorado, what we've done there, what might be relevant for y'all. So in terms of our current stack, this is what our Colorado stack looks like. New things are that we have, you can see that we have got FDIO in there, which we did not before. So we've done some initial work with VPP integration. And then also we continue to sort of support the three open source main open source SDN controllers. And yeah, and so sort of in terms of the things that we did in this release, not much has necessarily changed in terms of the integration testing and features, sort of a continuation of a lot of the projects from our Brahmaputra release. So what's new? First thing up that I think you might hear about are service function chaining improvements. So our last release, we had very initial service function chain capabilities. This time we introduced multiple node support, failover and load balancing, dynamic service chain modifications. We also do support NSH. At this juncture, and we basically were able to incorporate Open Daylight Boron, which is their most recent release and came out about 3 days before ours did. And so they've been working really hard to get a lot more features around the service function chaining, and we were able to do a lot of end-to-end testing of those. So we are able to actually compose the platform, use Attacker from OpenStack to install some actual VNFs, set up various service chains amongst those VNFs, and validate that they work. We improved our IPv6 support. So Brahmaputra, we did some initial v6, so this is very exciting. And we were able to basically add in the ability to test v6 only scenarios this time. We've got full overlay and underlay support within IPv6, and additional installers can support v6 installation. We, over the course of the past 2 releases, Open Daylight, the Linux kernel, and OpenStack all sort of considerably improve their v6 support that sort of enables us to be able to do this. Our SDN VPN project also sort of lots of enhancements since last time. Last time we had some basic layer 3 VPN support. This time we've got full layer 2, layer 3 support. We do have implemented BGP peering, and we've got integration. We added also integration with the Quagga BGP router. Another thing is, as I mentioned before, initial VPP integration and support through what we call our Fast DataSex project. A lot of updates on security. So we actually achieved the Core Infrastructure Initiative badge this time, which is a Linux Foundation project that focuses on security projects. And they've come up with a set of best practices for open source projects. So we attained that badge, and we actually kind of through our scanning and work, we're able to get, we actually found, I think, about 12 to 15 security specific related patches that we actually updated heading into the release. And we got to exercise our security vulnerability escalation and management and reporting process for the first time 2 days before the release. So that was exciting. We do now support sort of multi-hardware architecture support. So we fully support ARM as well as x86. And we've got some ARM test labs in our Pharos Federated Community Test Lab project. And we, as we always do, we focus on sort of, adding in more tests, automating more tests, and getting the DevOps CI/CD processes, even better. So that's always one of the things that we do. So in terms of things that are next, we are hosting our second Plugfest at UNH IOL in December. Some of the focus areas that we're really looking to focus from an interop perspective there are around sort of, hardware and NFVI interoperability, VNF interoperability on sort of different NFVI implementations, and SDN controller interop. Our next release will be called Danube. It's coming in March. And this will be the first time we're going to really probably have some Mano support. So we are working right now with OpenO and OpenBaton on the Mano side. We've also got some other projects going on around VNF event stream, modeling. So we're actually going to start testing using some of the standard netconf and Yang and Tosca models out there, actually trying to onboard and provision VNFs using some standard models, and just continuing sort of the feature improvement that we had in Colorado. One of the kind of the themes of the Colorado release was sort of more incremental improvements, in terms of the software we did. We sort of, the features that we'd introduced in Brahmaputra, we just made them work better, and we'll kind of continue on with that. And one of the other things that we're sort of looking at that's, maybe a little bit more dev-centric, is really we're beginning to think about how we can integrate our tool chains with some of those other upstream projects so that we can, automate all of the integration and testing and stuff even further and get sort of bug information to upstream developers even more quickly. So, and then, so that's kind of the update on Colorado. And then kind of just finally my sort of just final question is I would, love to hear how folks think that sort of OPNFV as well as the other Linux Foundation networking projects, we've got a lot of them, right now. How can we continue to collaborate and build, good relationships and bridges, with the IRTF and the IETF? We work and we're implementing a lot of the sort of standards that y'all are working on here. And, I do personally think that sort of, working together hand in hand with open source and standards is, one of the important things as we transform the networking industry. So if you have any ideas or thoughts here, always feel free to reach out to me. And if there are other touch points, we're looking at maybe some, maybe Hackfest collaboration and things like that. But, I really want to see basically our communities have great relationship.
Okay, cool. Thanks, Heather. Any quick questions? Okay, thank you very much, Mr. Flight. So OpenFE is probably one of the say most relevant projects to this group. So it's really also useful as an experimentation platform. So please check that out. Let's continue. So next is an update of the policy-based resource management draft. And you have the floor.
Well, hello everyone. This draft is about policy-based resource management. I am In Sanjang and PhD student in Korea University. I have been working as one of the contributors for this draft. Instead of authors Robert Singik, I talk about the update of this draft today because they cannot attend this IETF. There are changes in version 2. We have at this section 5.10, which describe operational policies for resource management that NFVRG and Vim and Vim. We have added new sections, for examples of policy-based event forwarding graph management and policy-based port management. These are operational policies for resource management. At first version, we define the operational policy in section 5.1, which supports business logic realized by domain ownership. So we specify these operational policies needed for resource management. The operational policies can split to different layers of NFVRG and Vim. Regarding operational policy at NFVRG, we include authentication, authorization, accounting AAA policy, providing ways of identifying resource requests, allowing access to NFVRG resources, and measuring the consumed resource usage. Also, resource adaptation ID policy support how NFVRG adapts the allocated NFVRG resources for handling dynamic changes, such as varying states or failure in NFVRG1 resources. Resource scheduling RS policy provides how the resources are allocated to VNF and VR instances network service across POPs under multiple VIMs and WANs. Regarding operational policies at Vim and Vim, we include resource allocation array policy and resource embedding array policy. Array policy supports how each subsystem, such as compute or storage subsystem resources, is allocated based on the allocation information coming from NFVRG. A resource embedding array policy determines how the allocated virtual resources are associated with physical resources regarding virtualization solutions. In addition, we have included new examples of policy-based VNF forwarding graph management and port management. For describing these examples, We refer to contents provided in reference, the reference management service chain by Swing Lee as one of the emerging draft. This example describes VNF forwarding graph placement policy regarding RS policy, in particular by considering features of VNF forwarding graph and recovery policies regarding RD policy for a failed VNF in a VNF forwarding graph. But we need to discuss this example more details as a next step. Regarding status, we still have no change with content structure, some same definitions, scope, and contents coming from 3 adapted drafts. But we need more discussions about the scope of these drafts. Regarding next steps, these are still missing. So we needed to review and update to draft the scope, goal, and structure based on the 3 adaptive draft. Also, we would like to include the relations to the service function chaining control plane and identify gaps with service function chaining. Also, we need to clarify differences between resource and capability management mentioned the last time. These are authors of 3 adaptive draft. That's all for my presentation.
Okay, thank you, Isun. Do people have comments, questions? Can I just ask, I mean, who has actually read this update? Okay, so that's not overwhelmingly many people. So we need to work on that, I think. So if we adopt documents as group documents, I mean, that means we want to evolve them together also, right? And so the authors really also need your feedback.
Okay.
Any other comments or questions? Okay.
Thank
you
you
very much.
Thank you.
So Carlos is next, right?
Yeah.
So next is NFVRG gaps for network virtualization. And Carlos is presenting.
Okay, I'm Carlos Bernardos, presenting an update of the draft on network visualization research challenges. So just a brief recap of the history of the draft. We initially presented in Prague, and then was adopted after Yokohama, and since then we have done a couple of iterations. Well, actually, we did one first presented in Buenos Aires, the first research group document. Then we did an update in Berlin, and since then we have done a couple of updates that are the ones that I'm going to just present next. So first, in terms of the goals of the document, well, the main goal is to identify and describe some challenges, again, around the network virtualization area. And those have been based on an analysis of different gaps that are existing today based on surveying different efforts. And we have recently changed the title of the document just to reflect better this goal. Before it was called Gap Analysis and Network Virtualization Activities, but now we rename it to Network Virtualization Research Challenges. So basically focusing or highlighting this main goal of the document. Then in these latest revisions of the document, we have mapped these research challenges to the near-term work items of the research group. And we are also providing a mapping to how or where these research challenges may be tackled inside IETF, IRTF in terms of working group research groups. The document structure, the current document structure is the following. The first part has not been modified significantly since the version 01. It's basically introduction, terminology, and the background, where we just summarize main technologies related to network virtualization. And then we go into the actual challenges and some conclusions out of those. And this has been improved and updated, both the structure and the content in the last 2 revisions of the document. We basically group some of the challenges in bigger topics, and we introduce new ones based on the feedback gathered on the mailing list. We received quite a lot of input for these new 2 iterations of the document. And in addition to that, we also have a first section on the mapping to the working groups where there may be work to be done addressing these challenges, and one new section on the mapping of these challenges to the near-term work items of the group. So it's just, we believe that this will make the document more valuable because it will be clearly mapped these challenges towards the work that the research group is actually looking at. So here is just a bit more details on what I just summarized. The changes in 01, so the ones that we have done in 02 and 03, has been adding these new challenges, these sections on virtualization technologies, metrics for NFV characterization, improving usage, and user device virtualization, and some other stuff. Well, most of this has been thanks to the input provided by you guys on the mailing list. Special thanks to Nicholas Khan and Senua Dixit for the text that they contributed to 02 and 03. And we actually have ready text from Pierre Lins and Pedro Martinez, Julia, on some additional stuff that couldn't make it to the 03 because of the cutoff deadline, but we will actually introduce this text in 04 version, probably this week or next week. Just some few works on this summary section, which I believe are very important for the value of to the research group. The first one, mapping the research areas that we have on the left-hand side here to the potential home at IETF, IRTF, where those challenges may be addressed. This was already there in the 01 version. We have just improved and updated it. And then the new section that is summarizing or basically categorizing the challenges that we identify in the document and put it there, or doing a mapping with the near-term work items in the group. So we believe this is also very useful because that can be used for the research group to actually identify which areas have more gaps or more research challenges to be tackled. So that's a quick update on this, what we did. So next steps, as I mentioned, to come up with an update 04 version, including the additional contributions that we have received, the one from PLX on testing and the one from Pedro on IoT and mobile operator virtualization. We have also received some hints from Diego on how to add stuff on remote attestation for another document done in I2NSF. So we include all these contributions in the next revision. Usual, if you have any additional comments, please provide that. We will be happy to get that into account and to introduce that into the next revision. And at this stage, we believe that the document is quite mature. We believe that it's useful for the community at large because we survey different challenges and we try also to identify where those may be tackled. So we would like to get your opinion on the possibility of starting a research group last call after the next iteration, the next cycle of the document. And that's it from this.
We have a Jabber scribe, so thank you.
Fantastic.
Yes, so from Jabber Room, from Diego Lopez, he says, maybe network slicing is a term associated with a particular environment. I'm thinking that a more general term regarding resource or function sharing would be more adequate in the RG context. That's his comment.
Okay, I agree that the network slicing term is heavily overloaded. So I agree that we may need to take a look at the current test and try to be more specific with that terminology, because I agree it's used for almost everything slicing nowadays.
Right. Do people have other comments or questions?
How many folks have read the draft?
Okay, a few. Okay, so you won't make any determination regarding like adoption now, so you're going to do this next revision anyway. So then would you like to ask for that in Chicago for the next IETF?
Yeah.
Okay, great. How happy are you with the feedback you are getting right now? I mean, you got some input.
Actually quite happy because we got quite a lot of input, actually real text that we just added. We actually have 3 contributions pending to be added. So far people was supportive and was actually contributing with text. So I'm I'm quite happy at this point.
Okay, great. Thanks for doing that work. And thank you. Can stay there. Yeah. So NFV multi-domain.
Okay, so again, Carlos, I'm presenting this on behalf of my co-authors. This is an update of a draft that we initially, well, we presented in Buenos Aires, I guess, first version. I don't remember, but for sure we presented in Berlin. It's about multi-domain network virtualization, multi-domain NFV. So the rationale of this document is that, well, NFV has not been really fully addressed in scenarios involving more than one domain, one administrative or technological domain. And we have here some examples. For example, from a point of view of a pure infrastructure scenario, we may want to use resources, network, compute, and storage from different administrative domains, and this is not really fully tackled. And we can go into more complex scenarios in which we don't only talk about resources, but we also talk about network functions, network services instantiated in different administrative domains. So the goal is to actually allow this programmability, flexibility involving multiple domains, and that's going into the final goal of significantly reducing the time required to deploy a service when invoking different administrative domains or when involving multiple administrative domains. So this is the NFV reference architecture. Sorry, I guess you are all familiar with this, so I will not spend more time. Just to basically highlight that in this reference architecture, multi-domain was not really fully present in the original NFV architecture, although it's something that is being tackled, as we will see later in the next slide. So the problem statement, well, we know that there is situations in which we have available resources at different administrative domains, and we want to actually be able to use those in an end-to-end service. But those mechanisms required to do so are not yet there. So we need to standardize the mechanisms in order to be able to do so. So a solution is needed for dealing with both multi-domain and multi-operator, multi-provider resource orchestration, or well, actually orchestration in general. And we differentiate here multi-operator and multi-domain because even in a single provider, single administrative domain scenario, we may have multiple domains, multiple technological domains that we need to also make sure that we can orchestrate or put resources together into a given solution. So both things are required. So trying to provide an overview of some of the solutions that are being discussed right now in NFV in terms of multi-domain orchestration. This is one example that was described in the document from the NFV IFA that was published in July. And this is a first approach in which we basically split the NFVO into two different functionalities, the network service orchestration and the resource orchestration, the NSO and the RO. And we may have, for example, two different domains in which each of these domains provides some resources that can be used for others to deploy a service. So we have RO basically dealing with the management of the resources, and then we have an NSO on top that is able to manage the life cycle of the network service by using resources for more than one administrative domain. This is one approach that is being proposed there as an architectural possible approach. Another one is this one in which we don't split the NFVO functionality. So we have the whole typical NFVO functions and the different domains, and then we have an umbrella on top that is basically managing the life cycle of the services, interacting with NFVOs of the different administrative domains. So another approach that is being considered there. So what we document in the draft is basically the approach that we are following at a 5GX European project that is basically specifically looking into multi-domain orchestration. We presented this figure in Berlin, so we follow up on this split of NSO and RO functionality. I will not go into the details because we already presented this, and I want to present some additional stuff that we added in the document in the last revision. So basically, before going into our architecture in this 5GX project, just to make or to highlight the difference between multi-domain orchestration and single-domain orchestration. In a single domain, of course, the orchestrator is aware of the entire domain resources and has control over those. while in the multi-domain, we first need to be aware of the resources and the functions that are available at the different domains. So we need that kind of dialogue, that kind of exchange, and then we need also to be able to exercise control over those. And that exchange of information and control needs to be standardized. And this is basically the main goal of this 5GX project that we are basically contributing with this solution. So what is the main high-level architecture that we are considering at this point that we want to present and is documented into the draft? So basically, we have this multi-provider orchestrator that is interacting with other multi-provider orchestrators sitting in other domains, in other administrative domains, other providers. And we consider three main interfaces of this multi-provider orchestrator. One that we call interface one, that is basically talking to the customer, to the tenant. So it's the one that is actually trying to deploy an end-to-end service over multiple domains. Then we have another one that is basically talking or enabling the dialogue between different multi-provider orchestrators, which is interface 2. That is for getting information about what the others can provide, and then also to exercise the control of and the instantiation of those services on the other domains. And then we have interface 3, which is the one actually interacting with the different resources that we have in the provider, the different domains that we may have with the different domain orchestrators. And if we just take a look into, okay, this multi-provider orchestrator, what are the main functions that we need to actually implement? We have identified three main blocks at this point. One is the catalog, in the sense of getting information about what are the resources, the functions that are available at different domains. And based on that, we can also offer what we can provide to other domains over interface 2 and interface 1. We have also the topology management. We need to know about the topology of the resources in order to be able to then instantiate those resources, those functions on top of those resources. Then we have, of course, the orchestration functionality, the typical NFVO functionality in terms of getting a request to deploy a service. And we need to decide in which domain we need to instantiate with function. And that's basically based on the information that we got on interface 2, and then we will actually control, instantiate services, functions on the domains under the control of this NFVO and on other domains over interface 2. And the last part is the assurance management. Once we have deployed a service, we need to ensure that this service is meeting the SLAs that we may have in place, and for that we need to monitor first the use of the resources and how the service is behaving, and report on that over interface 1 to the customer. So this is very high-level picture of what we consider an architecture required to deal with multi-domain orchestration. So this is basically what is described in the draft at this point, and what are our next steps? So, well, we continue evolving this architecture definition, and we want to actually fully specify these three main interfaces, interface 1, 2, and 3, where, well, we are trying to identify what is the best place to standardize those interfaces. Of course, HCNFV is one key potential home for some of this. Then we are also implementing, as we speak, this architecture, and we are introducing new functions and validating and assessing the performance of this architecture in the 5GX project, and we will release part, if not all of this, as open source. So we will actually announce that when ready. And we are also experimenting how this behaves on a distributed testbed across Europe with different sites. We are, of course, looking for feedback from the group, and that's it from my side. Do you have any questions or comments on this?
Can you use the mic?
I'm Flink from Nokia. I'm curious about this topology management. Which topology it is managing?
It's topology of the resources. You need to know, I mean, from the point of view of connectivity, you need to know how the different domains are connected. Of course, the way these topologies actually advertise depends on the relationship you may have of the different domains. At the first, you provide a very high-level vision of the topology, and then you may get into bilateral negotiation, and then you can provide a more detailed view depending on the relationship with the different domains of those resources. But this is the topology for the connection, but also the actual resources that you may have in terms of compute and storage. So VMs that you can provide, this kind of thing. So it's topology of the resources in general.
And the topology information is exchanged over this interface too.
Yeah.
Have you considered already which protocol you are going to?
We are actually now looking into that. So for example, for the initial part of the very generic topology information exchange, we are using BGPLS with some extensions that we are developing, but we are considering other candidates. And this is for the initial. Then for the detailed exchange, we may go for a ad hoc protocol, or we can also extend BGPLS. This is being discussed at this point.
Thank you.
Parviz Yagani, Huawei. Sorry, I wasn't at the last IETF meeting. Could you go back to page 10? Yeah, page 10.
Page 10.
Yeah. Is this inter-service provider scenario or intra-service provider scenario, or both?
Both.
Okay, if it's both, then the catalog belongs to which provider? Because you have one catalog shown.
You have one catalog per provider. I mean, I'm just showing here the sum of the components here, but you will have the same thing here as well.
Okay, so and then you have the
customer.
Of course, the OSS, the top layer.
Yeah.
So there is a reference that we can get the details. Yeah.
You mean a reference document of this thing, or?
Yeah, because this. You call this like an architecture or what? Maybe I'm missing something because I wasn't the last meeting. To me, the assurance management, assurance from which perspective, to which operator?
To the customer here.
Okay, so it's the same thing on the right.
Yeah. But the point is that the customer may be here, depending on, I mean, the customer is facing one of these multi-provider orchestrators. But there may be different customers, and you may have customers here, sitting here, getting a service that also involves resources in this administrative domain. So this assurance management component is basically ensuring that the SLA that you negotiated with the customer here is actually met, and providing the feedback, monitoring results to the customer, and basically checking over interface 3 on the resources owned by this domain, and over interface 2 on the resources owned by or managed by other domains. And your point about the reference, you were talking about the reference document where we put details on this, or?
Yeah. You need to show if this is the top layer, then layer below you had the split architecture. Yeah.
Mm-hmm.
You're assuming that this is the top NFU, the top layer, and then you still have the SO and NO or RO. You still have those layers, yeah?
Yes. I mean, this is a very high-level view that we put into the draft, but there are some, actually we are about to release a public deliverable of the project where we go into really all the details, because it's more complex than this. So we have different boxes here. This is NSO, we have different components here. We have different components here. So as soon as it's really published on the web, we will also send an email to the mailing list so you can get
one more question.
Details.
What's the difference between the IF1 and the one that is already defined in ETSI architecture framework, like the OSS and the NFVO is already defined? Is there a difference?
The OSS?
Yeah, there is already a reference defined. Their connection.
You mean, okay, you mean?
Yeah, if you go to this one, you know OSMA, MA on the top.
This one.
Yeah, what is the difference between OS-MA and IF1? Is this a subset of the IF1, or is it a superset, or what?
This is something that we are still looking at that, but as far as I know, I'm not, probably I don't know all the details of this, but here you don't have this kind of catalog information about what you have in different domains on this interface, right? You don't have this kind of information there. Because, sorry?
Per customer.
You need to be thank you.
Okay, so
Come to the mic.
Maybe people following online, so.
Yeah, online?
No, use the mic, please.
Okay, sorry. Oh, yeah. If you really look at this, you have the customer which has their legacy OSS BSS today.
Mhm.
And then you have the new like Manu stack. The exchange between the legacy system and the Manu stack is already, at least that was the intention of ETC NFV ISG, that you have that reference point. I believe that in phase 2, they're already working on how to get a normative requirement for that interface, correct?
I guess so.
Okay, so that gives you the scope of IF1. So now you're saying that's part of this work, you're going to include IF1 in the scope of the work.
Mm-hmm.
Maybe you can leverage the work that has already been done.
Yeah, sure. I mean, of course, this interface one, as well as the other ones, they are not meant to be like completely new things. I mean, we aim at leverage on existing work as much as possible. So this is not, I mean, something new. Actually, this is a subset of functionality. For example, part of the functionality that we depict here as interface 2, as Hannu mentioned, is BGPLS, just one example. And there are other functionality. So we aim at leverage on existing stuff. And for interface 1, of course, if there is something already, I mean, we are in the process of evaluating what is there, what that provides, and what is missing. And if there are something missing, we will propose a solution. But if not, we will just leverage on what is there. So we are not trying to introduce a new interface thing if it's already there. I don't know if you see my...
Well, mentioning any solution is premature in my mind, like BGPLS. You cannot just randomly bring up a protocol and say, this is a good candidate. We need to justify that.
Okay. Yeah, sure. I mean, I just reporting on the stuff that we are considering evaluating, but this is not the final decision. And of course, we are in the process of, when we take a decision, we will justify why. Yeah, for sure.
I'm just a physical representation of the remote queue.
I get to press the button. Do it. Let's try it. Diego, can you talk?
Yes. Hopefully you should be even seeing me, I guess. I don't know. Hello. This is Diego Lopez from talking from Spain. No, there is one thing is regarding what Parviz was commenting. I don't think that IF1 matches well with the OSMA interface, mostly because the OSMA interface is intended precisely to support legacy operators OSS. And my understanding here is that the IF1 here is dealing with the tenant. That implies dealing with the user of the customer, of the operator. So the tenant is making requests, right, Carlos?
Yes.
And second, looking at it, I don't know your plans, and I'm thinking about our document publication, etc. Since this is very much related to precisely resource management, because the multi-domain scenario, in my view, this multi-domain scenario has to do a lot with resource sharing. Precisely, I was wondering whether some of what you are discussing here could go precisely to the draft that was presented in the 2 slots before of this one by Jiang, if I remember his name.
Yeah, I think.
Yeah.
No, go ahead.
No, go for it. I
think that's a good proposal. We can discuss with the guys of the other draft. I fully agree that is in line with that view of resource orchestration. Yeah. So.
You have a very good point of contact, because Robert is among the authors of this, and Robert is one of the editors of the other documents. So it would be part of a self-discussion. Simply that. Thank you.
Thanks, Diego. And thanks, Carlos. So we're looking forward to the implementation and experimentation results. Yeah. Great work. Thanks. I get to hit the button again. Okay. All right. Moving on. So next is, let me pronounce the name correctly. Or maybe better you do it. I'm sorry. So network coding and NFV.
So good afternoon. My name is Ángeles Vázquez Castro. So I had to change also the name of the draft because it was too long. So netcode stands for network coding. So please.
You can use the clicker if you find it.
Here. Ah, okay. Okay, so this draft is a bit different because it's still in the, it's a bit conceptual, and I am still in the process of matching concepts. So that's why I explain why this draft first, then why this draft here, and then what are the objectives of the draft, and then the structure of the draft, so to ease your reading. And then what I see can be still done, and then that I would like to know your feedback from. So why this draft? Okay, so this is because the novel concept of network coding can be seen as a network function, CF. And this has some operative advantages. So however, this network function is not a traditionally implemented network function in dedicated hardware, which is what you are used to call a network function. But you may be aware of the coding, what the coding function, classic coding does, which helps to provide quality of service, trading delay and throughput. So this is something like that, but the generalization of that. So this will be helpful for this framework. This is because this network coding concept enables in-network optimized re-encoding, so we can access the packets in network and re-encode. And this is proved to provide throughput gains and network control degrees of reliability. So we have much more control on the reliability throughout the network, especially. So then why this draft here? Because as coding, I could just go to quality of service and so on. But the point is that if we think of network coding as a network function, it happens that the virtualization of such function has also operative advantages. Why? Because such function relies on having access to networking, computation, and storage resources throughout the network. So our function does need all this to perform. Then it also can work much better if it has access to network statistics analytics. And then it is also almost straightforward that this network coding function can be integrated into the network function virtualization framework, and as a possibility for architectural function design solution. And by doing so, we have access to all what we need for operating this tool, if you want. So this is why I first presented the very high-level idea at the meeting in Berlin, and I was asked to have a draft, so it's easy to get your feedback. So the objectives of this very high-level draft is first to show that network coding can be designed as a network function. What we do is to identify the modules, and the objective two is to show how this such network coding function requirements of connectivity, computation, and storage resources find a natural framework in this network coding function virtual architectural framework. But of course, we have to understand it from network coding perspective, meaning that people who have developed this architecture, they didn't have in their minds network coding at all because it didn't exist, let's say, or it existed only theoretically in the very, very theoretical research area, but that is coming here, it's slowly coming here. So if we understand all your work from this new perspective, it can be matched. That's the message. So this is just the structure of the draft. So these are my co-authors. We are two academics and two developers, because we have all these funded research projects. You can see here European funded projects, two from European Space Agency and one from European Global Navigation Satellite System Agency. So we are the others are developers. So we are matching concepts and reality, and so far so good. That's why I'm here. And so then the structure, as you can see, has this. First of all, what the network coding is as a network function, and then how we virtualize the network coding function. So one of the key things here is the virtualization of flows, which is something a novelty that brings this perspective. So I will just look at it. So in section 3, we explain network coding as a network function, and in doing so, we make clear that network coding is a broad concept. So it involves not only what we are presenting here, but it involves 3 design domains, different domains. It has the coding domain, and this is pure mathematics and algebra, and then it has the functional domain. That is the set of functional properties that makes use of these codes, and then of course the protocol domain to make it all work. So I don't bring here the coding domain or the protocol domain. I bring here the functional domain, but you have to keep in mind that there is these 2 domains too, and then. The way we make it as a function is to identify a toolbox of functionalities. So these 3 toolboxes, like the coding, re-encoding, and decoding functionalities, RDF, because of course the functionality makes use of decoding, but this doesn't mean that the user should know what the code is about. It's the same as in classic coding. The protocol designer just need to know how the code works, doesn't need to know the algebra behind. So here is the same. And then flow engineering functionalities, because with all this, what you are able to do is provide quality of service by engineering your flows, and then of course the interaction with the physical abstraction functionalities, which one option is the virtualized framework. So just the section 4 is the straightforward virtualization, which would be our set of functions would be just one of those well-known boxes. And I just highlight here this important differentiation aspect of network coding, which is that it also allows to virtualize the flow. So the flow of packets, we can have a mathematical model for it. So this makes network coding be a natural thing to integrate into virtualized frameworks of abstract entities, including not this framework, but also this network slice thing, which I look forward to listen to. So this is all. So to be done from our perspective is, of course, more detailed descriptions, but this is just, let's say, easy. What is challenging now and interesting is the conceptual matching. Then detailed examples, because to demonstrate what is this useful for you and then also the connection to other virtualized concepts like this. So thank you very much.
Okay. Thank you, Angela. So,
sorry. Questions? Who else read this draft?
Okay. So I had a question. Do you have any, driving applications? What is the main idea? I mean, is it improving reliability, or do you have say higher layer application requirements?
Yeah, we. It depends on which in which part of the network you are, but from the inner network, for as far as I see, there is it seems that in order to fix failures and reliability problems, there is over provisioning what is used. So then this is a solution for that.
Right.
For example.
So you are investigating different use cases?
Yes, but I think here this might sound better, this inner core over-provisioning problem.
Okay, okay.
So.
No, microphone. So next time, if you bring this back in, I think calling out a couple of the use cases that you're thinking of would be really helpful.
Excellent.
Thank you.
Thank you.
Yeah, this is more a clarification question. The scope of your work is contained in a VNF. Is that what you're proposing? Or is outside the VNF?
Diego's at the... It uses VNF. It uses it.
You define a new VNF?
I define a new VNF, but also a different understanding of the framework.
No.
I'm sorry, we are over time, and we'll have to take that question to the list. Behind, you can come up. Diego's next, though. He was in queue.
Okay.
No, please. You have two
Thank you.
questions.
No.
Diego,
So we already
don't run away, Angeles, please. No, it's simply a couple of things. One is that Simon Pietro Romano, who's one of the people in the Miteco team, was saying that they were supporting, or they were willing to support this draft because they see use cases for it, just as a note. So the people that are enabling me to be interacting with you is happy with this idea. Mostly because they are thinking about satellite scenarios. I was thinking something that came to my mind is in many scenarios I have seen about VNF deployments. One of the ways in which people proposes to guarantee a certain degree of mobility of the VNFs is precisely by using load balancers. Because everybody think about the load balancer, being aware of the different instances of the VNFs and scheduling or delivering the packets to each one of the VNFs. I was wondering whether, in this case, we could think about one of the potential applications of network coding would be precisely to substitute this need for a load balancer by this kind of a coding network function that you have presented, because it would be a real architectural advantage.
Yes, I think so. It is a quite advanced use of network coding. Yes. It requires to, as I was saying here, to virtualize the flows to get what the properties of every flow have, and then with having access to the statistics and the design objectives you look for each of the flows, then you balance with the relative redundancy of the different flows.
Yeah, following the suggestion from Sarah about the use cases, I would be more than happy if we can, discuss this a little bit in more detail and probably come to Chicago with some discussion of a use case precisely about load balancing. I'd love to.
That would be great. Yeah.
Okay.
Excellent. Thank you.
Is there a question?
Hi, I'm Kyle LaRose, Sandvine. I guess I'm just I'm struggling with what needs to change with the sort of architecture to fit this into it. Is it that there's concepts, understandings of the functions that need to be told to orchestrators, to the infrastructure managers that aren't being sent with the current protocols, current data models? Is that what we're trying to get at with the draft, or are we just trying to say that, hey, here's a cool thing that can fit into network function virtualization?
Mm. I didn't get exactly what is the question.
Are you with the draft? Are you trying to suggest extensions or changes to the sort of current standards for NFV, or are you just informing people of a new use of it?
Yeah, in my opinion, if the concept is seen useful, then some of the blocks and of the functionalities that are in the framework needs to be sort of not, I don't know, modified or extended or something. Yes.
Okay, thanks.
Okay, thank you. Thanks again. Okay, so this concludes the set of presentations on drafts we had. Now we are moving to the section where we talk about research projects, open source activities, and so on. And yes, please.
Can we find the blue sheets and make sure those are being signed by everybody who's coming in? Can we circle those around again, please? Where are the blue sheets right now? In the back? Would you mind handing those in the back row and we'll start making their way forward? Thank you, sir.
Okay, so next speaker is Pedro, and he talks about automated resource control in virtualized network environments.
Okay, I am just presenting the initial idea to gather challenges for especially network function virtualization. And first, this is regarding the automated, as the title says, automated resource control in, of course, virtualized network environments. And I start with the typical layered infrastructure we know, where we have the customers or clients that are pushing requirements, but also they can push other things, other kind of events in this case, or incidents and things like that. But we also, and then they are pushed to one controller. That is what we have called, and in many places it's called the virtual resource controller. That is within the virtual network operator in this case. And that entity has to deal with the underlying infrastructure through, of course, infrastructure providers. And it requires to use some kind of interfaces. Okay, but those interfaces today are difficult to be standardized. But in general, what we have put more attention is that even though standardization of interfaces may be not strictly necessary, because we can use some kind of adapters, it is important that they are offering the same functions. So what we have called idempotency. So they are not idempotent, so the virtual network operator cannot rely on different providers, different systems in the infrastructure layer without having reduced functions in one provider that other providers are offering. Okay, so here we state the challenges. That is to be to get some common set of functions that underlying providers must use, and if possible, they of course provide them through a more or less standardized or well-known API. I have included some examples for Open Daylight or OpenStack using the REST interfaces. But apart from that, we also have identified that the notification of the state of allowed allocated resources in the underlying infrastructures is not well covered in the different proposals for the provision of resources. So, you know, polling the REST interface is not a good approach. So a push approach should be used. And we encourage to include some kind of a notification approach in the underlying, and also this kind of notification should be more or less common, so the virtual network operators can interact with different providers using the same, expecting the same, in this case, concepts, notification concepts. And finally, in order to ensure that all of this is more or less common in different working, in this case in IETF working groups or even research areas, we propose we found the challenge in this case, to establish a common ontology, a set of concepts and relations between them that can be mapped to different architectures or different solutions. That is regarding the resource allocation, but we have also identified some challenges regarding the support for machine-to-machine communications, and especially the Internet of Things. And in addition to what I have just mentioned, we also identified that in some circumstances, IoT objects and devices that are building their own ad hoc networks, for instance, they can need to relay some of their functions to infrastructure, to cloud. And some of those functions should be location dependent. So we have well, so this can be provided by what it was called the fog nodes. So to accomplish this scenario, we have also identified the need to provide some kind of location semantics through the interfaces for the for the infrastructure providers. So, like, for example, specifying that a set of things or even an individual thing requires some kind of computing node in the location that the thing resides, so as close as possible, because of different things that are interacting to each other require that computing power close to them. And also, they have to, in this case of the computing, but they have to reference the same element regarding also location-based to the network resources, like, for example, to link those computing nodes to the things themselves. So this requires the IMP, the infrastructure providers, to expose also, apart from cloud, also fog resources, with little hassle for consumers, I say, and in general, this requires mechanisms to interconnect data planes of things with cloud and NFV providers in general. That's all from my side. Just the very initial work in this sense, and we wanted to discuss with you the main challenges we have identified up to now. So that's it. Thank you.
Thank you, Pedro. Do people have questions?
How many folks have read the draft?
There's no draft. What are the next steps for you in this work?
Our next steps actually are, we are working in the virtual resource controller itself. So our next steps would be to find some kind of set of functions that such virtual resource controller requires from lower layers that are not currently provided by already existing solutions. This is regarding the NFV, especially the NFVRG. So that to gather that set of functions and expose them to the NFVRG team.
So are you implementing that on some platform, or is that?
Yeah, we are actually in the very early research phase, but we are intending to implement that virtual resource controller, let's say, mechanism or system or whatever you say.
Okay. Good. Yeah. Thank you very much.
Thank you.
Okay.
BNF benchmarking.
Yeah. Okay. Rafael.
Okay. This work is about a VNF testing framework. It's a prototype, ongoing prototype, in partnership with my advisor, Christian Rothenberg from University of Campinas, and my colleague of research, Robert Sabo in Ericsson Research, Hungary. So it's based on previous works presented in NFVRG and BMWG. So I'm going to talk about the design, implementation, some partial results that we have. Basically, we all know that VNFs are like software components that can be instantiated in different virtualized environments. This comes from the ETSI NFV architectural framework, and that these virtualized environments can be different, can be heterogeneous, can have different capabilities to offer to the VNF, accelerators, and different platforms. And we also know that not only the environment can change, but also the VNF itself can change. Thinking about the VNF developer perspective, in a continuous integration, the VNF can change really fast and be deployed in different environments itself. So in this case, we believe that VNF descriptors, in the sense of the ETSI definition, can define also some performance profiles, associating, for example, metrics of network, like throughput, with the allocated resource, for example, the virtual CPU. And based on this, we proposed initially in the NFVRGs a draft some time ago that is expired. We are under review now. This initial proposal called a VBAS. It's a VNF benchmarking as a service. Initially, it's a standalone framework that have an interface to service with the NFVO and the VNF developers to define this idea of contact with some certain definitions of VNF benchmarking profiles. That means the developers specify how the VNF needs to be benchmarked, associating the possible metrics with the resource allocated, and in return, with the deployment of these profiles and this benchmarking of this extraction of metrics in different environments, we believe that we can have an automated process to extract these metrics and obtain certain parameters associated with performance versus the relocated resource. So just to go through like a quick example of a simple workflow that could happen. For example, suppose that a customer would like to allocate certain VNFs, and the NFVO would like to know the resource available compatible with those VNFs to be deployed. So the VBAS itself could be like a standalone interface for the NFVO that could reach for the VNF benchmarking profile to be deployed. It could be deployed, the VNF benchmarking profile. This VNF benchmarking profile is composed of managers, some agents, and monitors to deploy the decomposition of elements that can extract these metrics from the VNF. These metrics can be defined back to the VBAS via an interface, internal interface of the components, and they stored in a information database of the VNF profiles that could compose the VNF descriptors. And in this case, the NFVO could reach these profiles and have a definition of the possible metrics that the resource that it needs to locate to reach certain metrics in the network. And so basically the framework itself consists of the implementation of the framework consists of these elements in orange here, plus some agents and monitors. I'm going to speak about it. So basically what it has like is a definition of the NFVO composing like a NFFG or a VNFFG with certain parameters to deploy a VNF in certain virtualized environment. In return, the system itself returns this VNF benchmarking profile with the VNFFG of the resource that needs to be allocated and deployed in the virtualizer environment, and then the whole process goes on. So what was prototyped in this case? It was this interaction of the system here, the main core of the system, the interface with the NFVO. These components of also the benchmarking information base and the VNF profiles information base, all together with the agents, the monitors. I'm going to speak about it. And these are the main interactions of the main core system with the NFVO that request the deployment of a VNFG. From here, we see that we have the VNF benchmarking profile information base that is like description of how the VNFs can be benchmarked. And here we see that there's like a parameter of configurability of it, that this defines that these procedures can be repeatable. Also, with the extraction of the tests and the extraction of the metrics using these components, the manager and agents and monitors to probe the VNF itself. You have the test itself, that extraction of the metrics, and this way that the metrics can be extracted and saved in a VNF information base with VNF profiles, and these results can be validated in different scenarios, in different composition for different VNFs itself, and the NFVO can reach them. So this is just a model of information of the establishment of the components and the information models that they exchange among themselves. I'm not going through these components because it's like extensive definition, but basically it's just from the main system. You can go down from the manager to the agents and the monitors and the probers themselves. The probers are the interface to the tools that you can extract the metrics, and the way back, and composing all these information models. So this is just an example of a metric. It's one of the messages, an instruction that a manager can send to the agents. For example, in this case, for a ping prober, and this is, for example, an example of a result of the instruction that we call it snapshot. This is simple examples of it. And so all of this was prototyped. The main core of this VBus, these agents and these monitors and the manager. It means that all these components are independent, or they're all coded in Python. Each of them is like defined by microservice. Like each one is like a pluggable component, and they're like standalone. They have standalone REST APIs. They're totally independent from each other. In the agents and the monitors, we have pluggable probers and listeners. Probers and listeners, in this case, are the elements that make the interface with new tools. For example, ping, iperf, packetgen. So it's easy to attach and install and load these new tools using these probers and listeners in agents and monitors. And there are simple workflows of interaction among these components using JSON RPC. So we are looking into 3 use cases in the prototype now that we're going to test it. So first is a software switch. We target like layer 2 traffic, simple traffic via packetgen, for example, iperf. And the second one is a VIMS. We are targeting like the decomposed components in containers and VMs, virtual machines, to see how we can get the metrics in a distributed way. And the third one is like we have a layer 4, layer 7 custom VNF that we are trying to see from the perspective of the VNF developer to see internal instrumentation, how it can help in the definition of these profiles. We know there are related work, OpenFVRG, and Todd as well is a platform in Go language now for testing distributed environments. We can integrate the components here with these two environments via the REST APIs. We believe that. And our related work associated with IETF, RFCs, and IRTF as well in drafts, we are considering all the definitions of the benchmarking methodology for network interconnected device, the RFC 2544. We are also considering the definition of the IP performance metrics framework, all the considerations of the metrics, composition of metrics in RFC 2330. Of course, we are considering the BMWG draft on VNF benchmarking methodology considerations. We initially even proposed some work. We are considering this benchmarking of virtual switches in OpenFV as well, this draft, for our prototyping and our use case analysis. And our initial work proposal was a draft on VNF benchmarking methodology that it's expired actually. We thought initially that it was too soon to propose this in the BMWG. So our approach now is more pragmatic. We are going to show the experimental results first, and then maybe come back and show the results and talk to the guys about the possible standardizations. With the NFVRG, we see the intersection in two fields of the charter and the VNF performance in modeling. That somehow to define these VNF benchmarking profiles, we see that we need to gain information. We need to gain information on how to extract this VNF performance metrics. And this way of getting this knowledge of how to extract these metrics, you're actually discovering how you can model the performance of a VNF. We believe so. And we also see that, of course, when you extract these metrics of VNF profiles, you can define analytics for visibility and orchestration. It's like how the NFVO would like to have these metrics associated with the resource allocation for possible allocation of VNFs in different ops or different virtualized environments. So what is done is the prototype of this on this initial VBAS proposal. We see this as an input for experiments and assist a possible standardization in the future. We are doing this test in the use case now. The next steps, we are going for academic publication, as I said. We are going to show the results, show the framework, the architecture, the definition of the messages, the interconnection, and everything. We, for sure, plan to open source this. Not only open source, we believe that open sourcing this tool as well contributes to the way of creating these VNF profiles. I mean, you could run as a VNF developer and create a repository of VNF profiles that people could interact to and make like big data analytics on top of it. And possibly with these results and everything and the discussion, we can go back to BMWG or an IRTF and NFVRG and go back to the VNF benchmarking methodology definitions. So that's the work. Thank you.
Thank you very much. Yep, questions?
Thank you for interesting talk. And is this tool for the...
Who are you?
Oh, Kohei Shimamoto, NTT.
Thank you.
And is this tool for the in-service testing or test for the development phase stage?
Sorry, could you repeat the question, please?
Is this tool for the in-service testing or test for the development stage for the...
Okay, this is an interesting topic, and I think it's included in the research of the use cases, because there's like the two definitions of how you can extract these metrics. If you actually define the behavior of the service, and you can extract then the metrics of the VNF, or if you can extract the performance of the VNF itself without considering the behavior of the service. Or we are considering here that the tool itself can provide the means to you can add, for example, in the case for the VIMS, we have the CP, like a tool for benchmarking the VIMS, and it's specific for the VMS for the VNF itself. And this tool is like has all the behaviors of how to reproduce the service itself, and it's attachable to the platform using the prober definition. And then you have the definition of the service. So we believe that this VNF specific, call it like VNF specific benchmarking in service, like as you referred to, it's possible to be made using this tool, or you can just make also the benchmark using like the VNF itself, the traffic, and without considering the whole service, or like a state machine definition of.
Thank you.
So John from SKKU. I think this is very interesting job, and but one question is that actually I distinguish this benchmarking and performance monitoring, and meaning that the performance monitoring that more in the running operation perspective. So, but looking at this something like the interaction between VVAS and the NFVO, but can also you are thinking that these benchmarking services can be used for performance monitoring in the learning operation or not?
Yeah, I mean, we said initially actually that the name of the tool actually changed now. It's actually a VNF testing platform, because you see, benchmarking is one of the approaches of testing, and benchmarking, validation, and dimensioning could be all like coexist depending on how the parameters that you're playing with in the contact of the NFVO. For example, in the case of dimension, you'd like to see how many resources you'd like to allocate to reach certain throughput, and this in this case could be the platform also could be used for that. And this is a case for a monitoring perspective. For example, you'd like to monitor the CPU and allocate certain CPU at certain levels, and the platform could be used for that too.
Okay. Regarding that, you're prototyping that you are using any open source for HJ model, or you're developing on your own this model?
My own, sorry?
Model management and orchestration, for example. I mean, how you gonna prototype this whole this module and hold this system architecture? For example, there was the model, right? NFVO.
Yes.
And the VVAS will interact with this model, right?
Yes.
And for this model, what open source?
Okay, the NFVO part. I worked in a previous project called Unify, so we have a kind of like develop my own NFVO that I can develop, that can instantiate containers and everything. It's a part of a Unify project. It was also presented in this. So I defined my own orchestrator. Possibly it's another moment can be also open sourced. And I'm using that interface, my own interface for experiments only. In the future, maybe it can be open sourced.
Okay, thanks, Rafael.
Thank you.
Okay, so next is Tayo Heum. Danke. Optimal service placement using pseudo service training mechanism.
Okay, hello. My name is Taeum Na. I'm working for network software platform research section in E3. The title of my presentation is Optimal Service Placement using Pseudo Service Training Mechanism. It came from Plain Mano, which is the one of the project in E3. It is funded by Korean government. This is the content of my presentation. Before I explain my mechanism, I need to introduce our Plain Mano as a background, and then I will explain the placement mechanism. It is consisted of 3 pages, and I will conclude my presentation. The definition of Plain Mano is playground for the virtualized network application. It is built based on open source Mano, and this is the reference model. Our virtualized infrastructure manager consists of OpenStack and additional functionality, and it supports 2 types of virtualization, which are virtual machine and container. And we implement additional link API to support point-to-point type of link. Because OpenStack only supports multi-point to multi-point. Oh, sorry. And we support GUI for the user convenience. This is the main page of our UI. There are a lot of icons. This is the list of the VNF, installed VNF, and this is the list of the network service. And user can handle their VNF through Play Store. By clicking this icon, then user can handle their VNF. User can install or uninstall, registering or unregistering their VNF. This is the to register their VNF, user have to fill in this format: the name of the VNF and version and software. They have to attach their software image and VNF description. Then this is a space for the producing their network service. There are 3 parts. Stencil, left side is stencil. It is the installed VNF is located to the stencil, and user by dragging and dropping this icon to the canvas, user can instantiate the VNF. And then using those tools, user can make a link among the VNF instance. And we support saving and loading network service through those buttons. And when network service is loaded, all of the VNF instance in network services starts to instantiate it. And make a link, and configuration of VNF instance also synchronize it. At this situation, we need to consider about placement for the network performance. Okay, in HC standard, we find the 2 draft document. It already mentioned about traffic localization. I think our work can be the one of the use case of traffic localization. And we use several HC model to handle our network service. We use VNF forwarding graph description to manage network service, saving or loading the network service. And we use a virtual link description and virtual link record. And we add additional parameter at virtual link description to implement our mechanism. That's our number of transaction and rate of transaction and amount of traffic. The goal of our mechanism is to get more better performance of virtual link by localizing service function. Localizing service function means minimize the number of entity in service function path. And we assume that it does not consider scaling or policy or failover yet. This is the overall process of our mechanism. It is consisted of 3 pages. Firstly, it calculates all of the link in the VNF forwarding graph and selecting pseudo virtual load. Pseudo virtual load means 2 or pseudo virtual load means service node is connected to service node, which is by the link which is have largest cost. And then we select available computing node from all of the computing node, and then conduct placement. At the first page, we use 3 parameter: transaction, number of transaction, and rate of transaction, and volume of traffic. at the link. We use this equation, and some parameters are normalized to alleviate the high variance. And then we select pseudo virtual load. In page 2, we selecting computing node. It filtering the computing node based on resource requirements of service node. And it make a list of available computing node. It means computing node have enough resource to accommodate more service node. If it is not enough to accommodate network service, then we change to the filtering value to minimum resource requirement in the service node. And we sort the list of available computing node in descending order. At the page 3, we conduct grid placement because it is similar to the multiple knapsack problem. So available computing node can be the knapsack, and item service node or pseudo virtual load can be the item, and cost can be the list represent to value of item. This is the figure. This figure shows the process at the page 3. Left side is the initial state of page 3. So the virtual load and available computing node is already selected, and then at this time it compare available resource with resource requirement of the virtual load. If available resource is larger than resource requirement, then it updates when forwarding graph like this and go to the page 1 to select new pseudo virtual load. At the time, in this figure, service node 1 is included to pseudo virtual load because T1 is larger than T3. It is cost. And it go to the page 3 and compare with resource requirement with available resource. If it is smaller than resource requirement, it go back to the previous state and conduct placement to pseudo virtual load. After then, it updates when forwarding graph and resource, available resource, and then it recursively conduct the mechanism. It going to the page 1. This is the last slide of my presentation. We apply this mechanism our platform, our Mano platform. It improve 40% of round trip time, and it improve 37% of UDP receive rate. And it shows a better performance for the loss rate of UDP packet and decreased round trip time and less CPU usage of the host node. Okay. And because our work is, we submit paper about our work, it is on the review. So I didn't include some detail in my presentation.
Right.
I'm afraid.
But if people have questions, you can probably answer.
Sorry?
If people have questions, you can probably answer them.
I think if you send me the email, that is probably...
Well, we have one question.
We have time here.
Okay.
Microphone. Sorry. There's a lot of remote attendees. Thank you.
Andy Veach, the quick question is, under review by whom, or do you anticipate this being published soon?
Sorry?
Is the paper going to be available or even in pre-release form?
Not yet. It is under review. I think maybe after 1 month, I think it is free. A little bit free.
Okay. Yeah, thanks for bringing that work to NFVRG. Are there more questions? So I just want to make one slightly pedantic comment, so don't take it personally. So we have to be careful. I mean, when we talk about standardization, right? So here in the IETF, we are normally not doing standards.
Mm-hmm.
So as a research group, we may be doing specifications, so like for experimentation and so on, but they're not on the standards track of the IETF.
Ah.
And this kind of keeps creeping in, and so it's kind of important to clarify that. But it's you're not the first one.
Got it.
Okay, sorry for that. Thank you very much. Okay, so next will be Hanu, I think, with an overview about mobile edge computing.
You have some time. You also have a lot of slides. So
Yes, but I still try to keep it within 20 minutes.
you're saying we are ahead, so no worries.
Okay, good. Okay, hello everybody. I'm Hannu Flinka and I'm presenting this on behalf of Nurit Sprecher. She was originally scheduled to give the presentation. I need to start this with a disclaimer. And I think this disclaimer is required by ETSI. So I present this ETSI work and status, but I do not represent ETSI by doing this. So this is the legal
Thanks for clarification.
part. Okay.
Does it work?
All right, so mobile edge computing, this has been a very popular topic. I think most of you have heard it. Everybody has probably heard it. The concept here is that we bring cloud computing and IT resources at the edge as close as possible to the end user. And from this fact, you can notice the characteristics of this mobile edge computing. It is a proximity to the place where the consumer of the service is located. It provides ultra low latency because it is skipping the backhaul communication and it doesn't need to have a round trip time to the centralized node, but we have computing resources next to the access point. It provides also high bandwidth, and that's because it has the visibility of the radio access and can leverage the radio in the most efficient way, and also the context information that we have from the subscriber and the device. And also it's a location aware, of course, because we are bringing the service as close to the user as possible. So these are the primary characteristics of it. The selling points of mobile edge computing are listed here, starting from the much improved quality of experience, again, based on the proximity and the bandwidth and latency that it provides. It also supports context-aware services. Services can be tailored to certain specific location, user, and other preferences. And it has possibility to use radio resources and other network resources efficiently. Especially this radio has been the driving force here, having the radio information server close to it. And if you combine those, it is expected that we are able to create new type of services which have not been possible until now, leveraging real-timeness, interactivity, providing analytic services at the boundary of the network at the edge, security and privacy, leveraging again this local information, and then its distributed nature. In terms of foreseen business benefits, probably the main point here is that it encourages new type of collaboration. It's creating new value chain, collaboration between the infrastructure provider, meaning the operator who is providing the access points, service providers, OTT providers, and application providers. By doing this, it's part of the business transformation. It targets new market segments, those that were not feasible in the earlier approaches, namely new enterprise type of services, verticals, and also to subscribers. Etsy had created, and also we as a company, a number of proof of concepts, and these are examples of the new use cases and applications that it's providing: video acceleration, augmented reality, connected vehicles, IoT analytics, and so forth. Etsy Mobile Edge Computing Industry Standardization Group was established 2014. Here are the primary companies behind this initiative. And the purpose of this industry standardization specification group is to create open and standardized IT service environment that is capable to hosting these third-party applications at the edge of the network, but still being compliant with the regulatory and legal requirements that are stemming from the fact that this is operator services and accessing radio capacity. So it's somewhat regulated environment to start with. So it's formed under the auspices of Etsy, industry specification groups, and as already mentioned, it leverages this visibility to real-time radio status and context information, and provides these new type of services and also value chains. Here are the current members of the team. This is not necessarily the latest, so there are other companies who have joined there. You probably recognize your own logo there. Interesting point here is that needs to be emphasized is that it reflects this expected new value chain. So we have operators involved, vendors, network equipment vendors, technology providers, application and content providers. So it's all the actors are actively looking into this and developing technology. So what does this ISG do then? The primary thing are these normative group specifications.
What's happening?
I need to go one back.
Okay. 27. I think you keep pressing. Is it possible?
The one with the API. Anyways, if you can help me.
I'll try.
So the primary product of this ISG are these APIs, API definitions. No, okay, no.
You know what? Let me unplug the clicker and help you.
Do so.
And maybe restart this one. You were at.
It's 7, I guess. Number 7.
So let's try from the beginning.
Good that I have time.
Yeah, thanks to the previous speakers.
Yeah, good. All right. All right. So these computing platform APIs are the primary products, and how they have divided. How they have divided the work is that there is a platform part of it, and then there is application, third-party application part, and then the APIs. This is the status of the current work. So far, what they have developed is the technical requirements, including use cases, framework and reference architecture terminology, proof of concepts, a number of those, service scenarios, and then a white paper that is showing how mobile edge computing is helping to materialize 5G networks. The work in progress at the moment, they're related to these mobile edge computing APIs. You see there a listing of the APIs. So there's API to access this radio information, location API, user identity, bandwidth management, and so forth. Then there is active work on integrating this mobile edge computing with the NFV framework and environment, and then there are these supporting activities to accelerate MEC solutions to the market. Okay, so the framework is pretty much leaning based on NFV infrastructure, especially the management part is something magical is happening.
Is this an autoplay presentation?
Okay, all right. So NFV is the, yeah, okay, that might be good. That might at least solves the rough one. NFV is thought to provide the management part of it. Key point here is that there should be a common orchestrator, that all these third-party applications can be provisioned in the very same way to this standard MEC platform environment. The starting point was 3GPP compliance, so the reference points are inherited from there at the moment, and finally it supports different types of deployment scenarios. The MEC server can be at the cell side, it can be an accelerator aggregation site, or then it can be in a cloud run, and finally even in the centralized core network. Next slide, please. Here is the current reference architecture, which divides the system in the mobile at system level, which deals with the provision and provides the customer-facing interfaces, how the customer, enterprise, or even end user can provision services from the mobile edge. Then the lower part is the mobile edge host level, which deals with the shared computing capabilities at the edge of the network. There is this mobile edge host, the biggest box there, where we have these mobile edge applications. These are these third-party, why not operator services as well, which are then accessing the mobile edge platform. And all these interfaces are going to be defined. The relationship of the mobile edge computing to NFV work is complementary. NFV is virtualizing network functions and appliance-based solutions in the cloud-based solutions, whereas mobile edge computing is providing a execution environment for these third-party applications at the edge of the network. So MEC is reusing these NFV functionalities, but the scope is different, focus and business-wise, different objectives. Next. It is a component towards 5G. It complements also SDN in addition to NFV. So, and especially how it's doing this is that 5G has very stringent requirements for throughput and latency, and the latency solution can only be met that we bring these services closer to the edge, and if that is accepted, then mobile edge computing is the way to go. Then there are these other additional benefits related to QoE and total cost of ownership and business opportunities. Maybe we can go to the next one. Let's leave this one. This is okay. So here is a flavor for you to see what kind of proof of concepts have been developed by ETSI. So there are 8 of those altogether. I'm only going 2 of them through. So now next, may I try?
Take your time. No.
No. If you go to the slide number 17.
Okay.
Okay.
17.
17. It's this one, yes. And why I want to bring this up is that this has been discussed in the IETF. So this is the application of this mobile throughput guidance proposal, what we have had earlier and still working on it with a number of other companies. The idea here is that there is this mobile edge computing server next to the eNode P, and this mobile edge MEC server is hosting radio analytics application, and this radio analytics application is providing throughput guidance estimates or hints to the video content server, that is deeper in the network. The video content server is then able, based on these hints, control the TCP congestion window, as well as choose the most suitable application level coding that matches this estimated capacity of radio downlink. Okay, so this has developed. We have presented the results of field trials of this, and it's quite promising solution. And next slide. Another example of how one can leverage this mobile edge computing. Here, the mobile edge server is a roadside associated again in the base station, and it is acting as a roadside unit for vehicle-to-vehicle infrastructure. And here what happens is that the application is able to recognize hazards and other problems on the road, and then warn those cars who have proper equipment that there is some hassle ongoing. This has been developed together with Deutsche Telekom, and in close to Munich there is a motorway called A9 where this has been tested, and in YouTube you can also see a video on this if you like. Okay, and then what is next? So the first period was 2015 and 16, where the foundations and these reference architectures were defined, and the use cases and box, and ETSI Directorate has approved next period, next term for the work, and of course what's going to happen is that ETSI is going to finalize the tails of the previous work and moving forward to new use cases and extending the domain. The next slide then shows the objectives for this release 2, and here if you look at the bottom, you notice that it's extending from mobile edge computing to multi-access edge computing. And this refers to the first box there and the left upper corner. So until so far, we have been looking at the 3GPP cellular type of networks, but in the release 2, it's extended to non-3GPP accesses, wireless LAN, and fixed network also. Also, other type of virtualization solutions will be considered and specified. There are these charging models that will be looked into. There's these regulatory gaps related to lawful interception and testing and these kind of supporting activities. Next slide, please. Okay, so this is concluding the presentation. So mobile edge computing is a key component in building block in the evolution of mobile broadband networks, and it complements NFV and SDN. It is identified as an enabler for new type of services, particularly IoT and mission-critical vertical solutions because of this proximity benefit that it gains. It is recognized to be a tool in a element in 5G architecture. You can also start to deploy MEC type of solutions in 4G and take the benefit there of using these new services also in 4G networks. And finally, it is expected to enable new type of applications and related business opportunities. It's entering the release 2 phase in ETSI. So that's the presentation.
Thank you, Hannu. So we have time for some questions. So I'm Dirk Kutscher. I mean, so in the IETF, in the transport area, so latency reduction is also currently a active topic. So I think essentially what people noticed is that, I mean, in in reality, I say most or not, or all applications actually benefit from low latency, right? So not only interactive real time, but also your web traffic, and so on. And so, I mean, there is this, there are like activities on like low latency, so like data center TCP, like approaches. Then we have started this new work on QUIC.
Yeah.
So assuming this all, gets implemented and so on. So what are the use cases that are left for MEC to optimize latency or to reduce latency further?
Well, even if you're using QUIC or these other more optimized transport protocols, it doesn't. Those do not resolve the issue of distance. So still, the distance is a factor because the signal cannot travel faster than the light of speed. So mobile edge computing is doing what is doing. It's skipping an order of hundreds of milliseconds in average case, bringing these critical applications close to the edge. So actually, this work so far hasn't taken any position on these improved transport protocols at all. It's what is leveraging is more of the locality of the services, the base station.
From Vodafone. So this low latency we want to have in 5G networks, this is not only related to the fact that we have something closer to the customer, which you're calling edge. In LTE, we have a technical limit of about 20 milliseconds between user equipment and the radio on MAC layer. Yeah. And on 5G, we want to bring this down with better silicon to roughly, we say, 1 millisecond.
Okay, yes.
Let's see. It's not the edge, it's basically the silicon. And when you say we say 20 milliseconds, it's a lot of 1,000 kilometers, and you have 200 kilometers per millisecond.
Yeah.
So it's a new silicon which basically takes care of this lower latency in radio networks. It's not the edge is also a component, but not the most important one.
Okay, that's true. So you're saying that the radio is adding the delay, and it's true that 5G radio is supposed to solve that.
You never would make this low latency stuff, this tactile stuff, and so we described some years ago with 4G.
Yep, correct. That's true.
Okay, let's see other questions. Let me ask one more. So you had this one use case that we also discussed in the IETF with the mobile throughput guidance.
Yes.
I mean, is this an advisable model where you, basically have to make the application server, the video server, for example, aware of what's going on in the base station? Is that something we want to have? Or?
Well, I have been involved in that work, so I have to advocate. Yes.
Yeah. Okay. Sorry.
It's very
sorry for putting you on the spot.
advisable. Actually, the draft carries my name also there. So, but yeah, yes, that's the. If you want to react to something which is happening in a very short time frame, the current TCP windowing is not able to support that, and especially if you are anticipating something to happen. Anticipating happens to something that this radio is a shared resource amongst many. So the single TCP session is congestion control cannot tell you as much what the access point or the base station can see.
Okay.
Then is the question of that how many percentage this improvement is. But what we have seen and and tested and reported here in IETF, the improvement is significant. We are talking about 30 to 50% improvement by leveraging this, let's say, metadata.
And okay, let me one final, if I may.
Yes.
So we mentioned at the next step the multi-access mobile computing.
Yes.
So is this basically just about enabling MEC in like non-3GPP networks, or is that also about so when you have like hybrid access or you have like soft handover or multipass access to have some like synchronization between those edge computing platforms, or could this be an issue if you don't have it?
Now, this is of my best knowledge, so it's not that this network is doing so. The latter one is 5G networks, that they are inherently going to be multi-access support at a very low level. This is what they're looking into. So it's PDC layer or maybe above. But this MEC solution it gives you quick start in multi-access so that you can also integrate these IP level and other fixed accesses into the equation without this lower level support.
All right. So
thank you.
So this concludes the set of scheduled presentations. So since you all very disciplined in timekeeping, we have some time left for any announcements, news that people want to share. So I think Alex had some news. Is he still around?
He wants to do it on the list.
Okay, Alex will do it on the list.
Where's the other blue sheet? There's one more floating around the room somewhere. Okay.
Okay, we will.
I guess we'll find that.
Find that. Thanks for coming. Have a nice evening. See you next time.
Please.
Wait, if you haven't signed, now's the chance.
Man, we finished.